Hello everyone, Assalamu alaikum. I am Saim Iftakhar from Rawalpindi. I have done Bachelor's of Mechanical Engineering from University of Engineering and Technology Lahore and Masters from Custis Lahore. Today I am going to teach you about the basic concepts of mechanical vibration. Starting with the lecture outlines, introduction to system mechanical vibration, basic requirements, some examples and types of vibrating systems, mathematical equations governing the for the calculation of natural frequency, and some causes of vibration in a system. Starting from some basic terminology, what is a machine? It is a system that takes some input energy and provides output energy as well. From the figure, it is obvious that some input energy is given to the machine. Some of part of this energy is lost and the remaining is output energy in the form of work. So all dynamic systems are capable of vibration. Vibration is basically the relationship between forces that act on mechanical system. This result in oscillating or repeating motion. Or in simple terms, we can say that vibration is basically a simple harmonic motion about any point. So scientifically, the definition of mechanical vibration. Mechanical vibration is basically the oscillatory or repeating motion, and in engineering terms, it can be defined as the relationship between forces that act on a mechanical system and causes it to move from one point to another or vibrate around a certain point. A dynamic system is combination of matter which possesses mass and whose parts are capable of relative motion. All bodies possessing mass and elasticity are capable of vibration. So basic requirements of mechanical vibration. Dynamic system undergo some vibration when subjected to some external forces. Mass and elasticity are the governing factors for vibration. Mass is inherent property of any body, and the elasticity is due to the relative motion of the body. Sometimes the excessive level of vibration is very harmful or objectionable for mechanical system. So a good mechanical design engineer has to control it to a subsequent level. These vibration can cause wear and tear of the part and loss of mechanical power. So examples of mechanical vibration motion. The figure shows the basic vibrating structure which consists of a mass and a spring system that has elasticity. So when the motion is maintained by the restoring forces, the vibration is called free vibration. So there are two types of vibration: free vibration and forced vibration. When the external force is applied to the system and periodic force that causes the motion or destabilizes it, this is called forced vibration. When frictional dissipation of energy is neglected, the motion is said to be undamped. Actually, all vibration systems are damped to some extent. Elements of the vibrating system. Three major elements: some inertia element called a mass, elastic element called a spring, and energy dissipative element called a damper. A simple mass spring system can be used to explain the vibrating motion. It may undergo forced or free vibration. Damped systems are vibration free, means some external mechanism is used to mitigate the vibration, and this external system is known as the damper. When the system is set into motion, tends to vibrate with its natural frequency, and the resonance occurs when the natural frequency of the system and the system frequency are at the same level. The mass oscillates or vibrates while the spring stores energy temporarily during the vibration and damper consumes to dissipate the energy. So these I have explained earlier: the mass, the spring, the damper. These are the basic elements of our vibrating system. So examples of vibration system: three basic different types of vibrating system: some axial or longitudinal, lateral or bending, torsional or rotational. Natural frequency describes the rate of exchange between the two types of energy storage elements. In above mentioned case, it is the mass of the body and spring system causes a simple harmonic motion. So simple harmonic motion is basically the repeating motion that tends to repeat itself after a certain period of time. So axial vibration, the following diagram shows the axial vibration that is along the axis of the body, called the lateral axis or longitudinal axis, and some lateral vibration occurs when the body is fixed at the certain end, and the torsional vibration occurs when there is a rotating or effect in the body. Simple harmonic motion. The simple harmonic motion is already discussed in the previous slides. It shows that the motion, that type of motion that repeats itself after a certain period of time. It has certain amplitude, it has certain time period, and it has some maximum upper position and maximum lower position. This graph shows the repetition of a certain mass after certain period of time. Period or time period is basically the time required to complete its one cycle from its original mean position to back to its mean position. From the previous figure, the oscillatory motion has the following parameters: time period in seconds, frequency in hertz, amplitude in millimeter. The time interval required for a system to complete a full cycle of motion is called time period of vibration. So it is basically the time required by the mass to complete its one cycle from and move from its original position to back to its original position. And number of cycles per unit time defines the frequency. Frequency is how repetitive the mass is completing its oscillatory or repeating motion. And maximum displacement of the system from the equilibrium position. So it is basically in the form of millimeter. Amplitude is basically how far the mass is going from its original position. Time period tau is calculated as 2g by m cycles per second. The frequency is basically the inverse of time period. So m over 2g cycles per second. Omega is the natural frequency of the system. So if x of t, x is the displacement and t is the time period in which it is occurring. So if x of t is the displacement of the mass, then velocity and acceleration will be the first and second derivative of displacement. So causes of vibration in a machine: coupling misalignment. If two mating parts or two joining parts are not at the same position or not at the same angle, then there occurs a phenomena known as misalignment. So parallel misalignment or angular misalignment, this may cause an imbalance in the vibrating system, and cause of vibration will be more. Mass imbalance. So mass imbalance is some body that has an axis of rotation, but it has a mass or center of gravity that has been displaced from its original center of gravity. So there will be an unbalance in the body. Eccentricity. Eccentricity is basically the displacement from its original center or epic center. Some other factors that causes the vibration are friction between the mating parts, wearing, tearing of parts, broken parts, for instance, bearings. Thank you so very much.